So in the first section of Chapter 6, we're learning how to solve inequalities using addition and subtraction. And then as we progress through the chapter, we're going to learn how to solve more complicated inequalities. So our objective for this lesson is to learn how to solve inequalities using addition and subtraction. The first thing I wanted to do is remind you how to solve, how is solving the inequality relates to solving the equation, and how the solutions actually look like on the number line. So the first thing we're going to do is we're going to solve equation x plus 3 is equal to 7. So remember that our objective is to get x by itself and get an answer. So get a solution. So we're going to subtract 3 from both sides, and our answer will be x is equal to positive 4. Now if we were to graph this on the number line, it would look like a closed circle at 4, because this is our only solution, x being 4. Now, with inequalities, it's going to look a little different. So first, we're going to subtract 3 from both sides. Now, the only difference is x plus 3 was not equal to 7, x plus 3 was greater to 7. So our answer will be x is greater than 4. And here, 4 is not actually part of my solution. So that's why I have an open circle to show that 4 is not a part of the solution, but all the numbers greater than 4 are. So if you think about our number line, the numbers that are greater than 4 are going to go to the right. So this is how we're going to graph our solution. Now for the last one, it's a little different because it's less than or equal to, but we're still subtracting 3 because we're still trying to isolate the x. And our answer will be x is less than or equal to 7. So now the equal to means that 7 is actually part of our solution. Okay, so I fixed my number line to have 7 on there. So we are going to find 7. And since my answer could be 7 because it's x is less than or equal to 7, we're going to fill this in to indicate the 7 is included. And anything less than 7 will also be included. So we're going to go on the number line and show that all the numbers that are less than 7 are going to be part of my solution. And we're going to remember to draw the arrow to show that everything else that is going to be on the left of the number line is still included, because any number that's less than or equal to 7 is going to be part of your solution. Okay, so we're going to learn how to graph an inequality on a number line. So in example 1, we have a word problem. So the highest temperature recorded in the United States was 134 Fahrenheit at Death Valley, California in 1913. Use only this fact to write and graph an inequality that describes the temperature in the United States. Okay, so the first thing we need to do is we need to define the variable. So since we talked about temperature, T would be a good choice. So the highest temperature was 134, which means that any other temperature is going to be less than or equal to 134. Since 134 was an actual temperature that was recorded, we have the equal sign here. And then we're going to draw a number line. And here's my 134. We have a closed circle because 134 was actually the temperature that was recorded, and anything that's less than that is also part of my solution. So this would be the graph of the inequality. So here's your actual inequality, and here's your graph. So here's an example for you to try. Read the problem and record the inequality and graph the inequality on your notes. Okay, so in skill number 28, we're going to learn how to write inequalities represented by a graph. So you'll be given a graph and you have to write your own inequality. So first we're going to start with A. I'm going to use x for a variable. It doesn't really matter, you can use any variable. So this shows me that all the numbers that are larger than negative or greater than negative 6.5 are part of my solution. So x will have to be greater than negative 6.5, or another way to write this is that negative 6.5 is less than x. Either one of these is correct. Just make sure that 6.5 is the negative 6.5 is the smaller quantity. So here x is larger and here x is larger, so make sure that it's consistent. So for B, it is a filled in circle, so we have to have equal sign in our inequality, and x will be less than or equal to 4, or I can say that 4 is going to be greater than or equal to x. So here, 4 is going to be the larger quantity because x, the solutions are going to be over here, so anything less than 4. 4 is going to be the largest number. So either one of those two is fine. Okay, so pause the video and try this one, and make sure to write down your answers. Okay, so in skill number 29, we're going to learn how to solve one-step inequalities using addition. So remember, our goal is to isolate the x, so we start with x minus 5 being greater than negative 3.5. So the first thing we're going to do is add 5 to both sides, and x will be greater than 1.5. So x is isolated, I have an answer, and the only thing I have to do is graph it on my number line. So I'm going to graph 1.5, it's right here. There is no equal sign, so it's just an open circle at 1.5. And then it's everything greater than that. So this is going to be my graph. Alright, so pause the video and try these 3 problems. Make sure to submit your inequality answers, and make sure to graph your solutions on your notes. Okay, so for skill number 30, we're going to learn how to solve one-step inequality using addition. And we're going to graph our solution. So we start with 9 being greater than or equal to x plus 7. Our goal is to isolate the x, so we're going to subtract 7. And we get 2 is greater than or equal to x. And then we're just going to graph it. So 2 is going to be greater than or equal to x, which means that it's going to be a closed circle. So here's my 0. Here's 2. I'm going to have a closed circle. And then anything that's less, x is going to be less than or equal to 2, so everything that's less than 2 will be included in my solution. Now you can also write this answer as x is less than or equal to 2. Remember, just make sure that if 2 is the larger quantity here, 2 has to be a larger quantity here, because you don't want to actually change your answer. And that's it. So pause the video and try this problem. Make sure you solve it and don't forget to graph it. Okay, so for skill number 31, we're going to write and solve inequalities using real-world problems. Alright, so this is the last skill for the section. We are going to learn how to write and solve inequalities using real-world problems. So the problem is about luggage weights. It says you're checking a bag at an airport. Bags can weigh no more than 50 pounds. Your bag weighs 16.8 pounds. Find the possible weight that you can add to the bag. So here's my inequality. So first, what I'm going to start doing is write a general inequality, and then I'm going to get more specific. So my bag weight has to be no more than 50 pounds. So I know this is going to be 50, and then you have to think about what happens when it's no more than 50. So do you include the 50? Do you not include the 50? So if it's no more than 50, you can be 50, but you can't be more than that. So we're going to be less than or equal to 50. So now we're going to get more specific. So our bag weighs 16.8 pounds. Now I'm going to use a variable here. Now this is going to be a variable that we're going to make up, so I'm going to use x here, but I have to define, oh never mind, we actually are asked to use a w here, and it was defined for us in the problem. If this wasn't defined for you in the problem, then you'd actually have to write down what the variable represents. In this case, we asked to use w for the possible weight. Okay, so 16.8 plus w has to be less than or equal to 50, and we are asked to find the possible weights. So what we're going to do is subtract 16.8, because our goal is to isolate the variable, and we get w being less than or equal to 33.2, and we're going to write a sentence about what this means, because this is the word problem, right? So find the possible weight, and you can say you can add no more than 33.2 pounds. So remember to use units because you were given units when we were talking about the problem here. So we want to make sure we're consistent and we use the units because otherwise it doesn't mean a lot. So um, this has to be pounds. And make sure that if you are answering a word problem, you actually write down the answer as a sentence because you were asked to a specific question. And that's it. That's your last you try example. So pause the video and complete this example. It's using example 5, so you might want to go back to the video and just pause it to see the description again. But what's going to change is how much your bag weighs. Alright, well, good luck, and that's it.